All right, welcome back. Part two. Here's question 5.29. What do school kids want? So the goal is we want to compare boys and girls and where they live, urban, suburban, and rural, and see if there is any differences that we notice. Okay, so what would you like to do at school? Make good grades, be good at sports, be popular. Okay. Now the problem is we want to compare these different areas, but obviously most people live in urban and suburban, right? That's where things are more densely populated. Um, so you would say, oh, well, why not just do an SRS of every school child? Well, of course, that really can't happen. There's too many school children. It would be too costly, too time consuming, etc. So that can't happen. So what could we do, right? Okay, so they're telling us we're going to start by choosing schools rather than children. Okay, so multi-stage. Describe a suitable design. So let's see, maybe we break schools up by area. So break schools up into three groups. All right, so we would have urban, suburban, and rural. Okay. So in other words, this is going to be stratified, random sample. Okay. Then randomly choose from each group. Okay. Obviously, we should kind of probably do it proportionally in some way, right? We don't want to pick, one school from urban and the rest from suburban and rural, but some type of stratified randomization takes place. They don't really tell me how many schools or anything like that, but this is just the idea. So randomly pick schools from each group, and then randomly pick students from each school. Okay, so multi-stage sample. Of course, you could go into more detail if they gave us more details. All right, last problem, systematic random sample. Okay, choose a sample of apartments. Suppose we have to choose 4 addresses out of 100. So that means we're giving each a 1 in 25 chance, right? So what we can do is pick one address, and then rather than doing an SRS and picking the second and the third and the fourth, we just pick one and then add 25 to it. That's what they're saying. And then add 25, add 25. So that's the whole idea of systematic, right? Like if I wanted to pick 1/3 of my class, I would just number my students 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, right? And then randomly pick either 1, 2, or 3. And now I've got 1/3 of my students, right? That's a systematic design. Okay, so they want me to use table B, again, random digit table, to select 5 addresses from a list of 200. So 200 divided by 5 is 40. So I'm going to find the first suitable address, and then I'm just going to add 40, add 40, add 40. Okay? So line 120, first number there is 35, so I'm going to take 35. Then I'm going to add 40, add 40, add 40, add 40. There's my 5 addresses. It was a systematic random sample, right? Because I could never get address 35 and 36. I could never get 35 and 37. I could never get 35 and 21, right? Once I pick 35, the others are set with it. That's why it's systematic. It's not simple random sample because, again, not every group of 5 addresses could be chosen. But this is still random. Okay, letter B. Oh, okay, I just kind of did that, right? the systematic random sample is random, right? There shouldn't be bias created, but it's not an SRS because, as I just mentioned, not every group of 5 has the same chances as every other group of 5. As a matter of fact, what we've done is set up groupings, and now we're picking between those groupings, and those groupings in this case are all 40 numbers apart. And there you go. That's why a systematic random sample is not the same as a simple random sample, or SRS for short. Okay, that's the end of it. Thanks for watching, and good luck.